Okay, hello and welcome to the channel. It's time for another live stream. Today we're studying Eigrp, and once again, before we get started, I'm gonna post the links on my social media, so perhaps we'll have more people join. So as usual, give me a few moments and I'll get everything ready. So let's find the link over here. You might hear my voice in the background, by the way. Right, copy. All right, here we go. By the way, as you may know, the Cisco Live conference is happening right now this week. So we might have some Cisco Live vibes later on in the stream, but we'll get started with the topics first. Okay, I think my battery is a bit low, so I'm gonna put my phone on the charger maybe. All right, let's do that. Where's my cable? Alright, let's see. I have everything ready here. I think so. We're good to go. Or maybe we'll just give it just a couple of moments. I see some people are joining, so welcome. Nice to see you here. Feel free to say hello in chat or send any comments, or, well, hopefully not any comments. Be reasonable. But yeah, any comments or questions are welcome. All right, I think I'll just get started. I'm gonna explain a couple of things anyway, so if people join later on, that's fine as well. So as I mentioned at the beginning, we're gonna look at Eigrp today. And actually I have my OSPF topology open here on EvenG, but that doesn't matter. So I've tested some things here using OSPF, and I think OSPF is still configured here. I'm pretty sure I just checked it. It's timed out already. So there shouldn't be anything too crazy configured here. Show IP interface brief. Yeah, only one interface as an IP address, and then I think there was some OSPF configuration. Show run section router. So you see that basic OSPF is also configured, but that doesn't matter for the purposes of this live stream. We can still run Eigrp at the same time. The only time where we might have some problems with it if we start advertising routes, and then depending on the administrative distance values, like some routes may not be learned or may not be installed into the routing table because of the lower administrative distance value, depending on what we want to do. But we're not gonna go insane today, so let's just try to keep it like basic. What else was I gonna do? Let me go back to the diagram here. Yeah, so all of the routers, they have an IP address configured from this network. So it should be like .1, .2, .3. And these are actually the only 3 routers that I have even running at the moment. We don't need the others. And to demonstrate the Eigrp configuration, I'm going to use this configuration guide. Even if I know how to configure some things like basic Eigrp by heart at this point, I want to familiarize myself with the documentation a little bit and learn where to find things, because it's not always clear, in my opinion. And based on my experience going through these documents. Yes, and then I also have the RFC open here, so maybe we can find some fun information. I don't want to install any drivers now. No, thank you. Yes, and maybe we can do some Wireshark packet captures as well. We'll see how it goes. So we can kick off with that. And, well, as I mentioned, configuring basic Eigrp, it's almost the same as the OSPF configuration right here, besides the area part. And of course, you need to be under the Eigrp routing process. And then even this command is optional, the router ID. The router was automatically selected using certain rules that maybe we can get into as well. But even if we know the configuration, again, I want to go through the documentation and see exactly where you can find that information. So let's actually do this. Let's copy paste this thing here. So the easiest way we could do Eigrp is like this. And that would work. But we'll leave that for now and then see here. What I also want to do is configure both classic mode and named mode. The configuration syntax is a little bit different, and I'm not so familiar with the named mode because I've used classic mode for a long time, and every time I do a lab to test something, it's just easy to enable Eigrp this way. So we'll practice named configuration mode as well. So in here, if we go through this document, let's see what we can find here. And actually, I guess here it's referred to as the Eigrp autonomous system configuration. So you see here, configuring the router Eigrp command with the autonomous system number argument creates an Eigrp configuration called the Eigrp autonomous system configuration, or Eigrp classic mode. Well, this is what I call it. I've also seen Eigrp numbered mode, but they're all referring to the same thing. And here there's information about the named configuration. So configuring the router Eigrp command with the virtual instance name argument creates an Eigrp configuration referred to as the Eigrp named configuration, or Eigrp named mode. And this is what I want to look at as well. So Eigrp neighbor relationship maintenance, so like hello and hold timers. And then also look at the difference between multicast and unicast neighbor relationships. And then neighbor authentication. But you can see in the beginning here, it's not really providing us with any useful information. Or I shouldn't say useful. But if we strictly want to focus on configuration, this doesn't really provide much for that. I mean, it did mention the router Eigrp, and then here it's talking about the address family. Actually, well, let's see what it says here. When the address family is configured, we recommend that you configure an autonomous system number either by using the autonomous system number argument with the address family command, or by using the autonomous system command. Why does it say it here under autonomous system configuration? I thought address families were configured with named mode. Anyway, let's see where we can find some configuration examples. Oh yes, the Eigrp metric weights, the K values. We don't need to worry about that right now. Floating summary route. Yeah, see, this is the confusing part with the configuration guides. So there wasn't really any configuration examples towards the top of the document here, or maybe, well, there was something about the K values. But just configuring basic Eigrp, I don't think it showed it anywhere here. No, it didn't. So it just jumped straight into configuring the K values. So here's how you can change the metric weights. And then there was something about summary routes right here. And also here, if you look at this, like VRFs are included in the configuration. So this is already quite advanced, and we're just at the top of the document where I would expect basic configuration. So this is what I mean, that the documentation is a little bit hard to navigate, in my opinion. Eigrp VNets, honestly, I don't even know what that is. Okay, here maybe we find something relevant. How to configure Eigrp. Okay, now it's looking way better. Enabling Eigrp autonomous system configuration. Okay, this is exactly what we want. So this is showing you all the steps, starting from enable, how you enter the privileged exec mode, and then going into the global configuration mode. And here's how you enable the Eigrp process. So that's how you would enable classic mode. So let's try that. Let's go on R1, for example, and do classic mode. And as I already mentioned, it's very easy. It's basically the same as the OSPF configuration with those minor changes. But yes, so just so we can have it in our muscle memory, I'll just like to type things out. We can use autonomous system number. Actually, let's change it from 1. Let's use 42, which is the answer to the universe. So router Eigrp, network 192.168, 255 and 0, and then this wildcard mask. I bet you that I'm gonna write router Eigrp 1, even though I specified autonomous system number 42 here. Just because I'm so used to typing 1, I swear you're gonna see it somewhere. And okay, let's go back to this guide. And actually, let me take some notes here, because I like to create those like PDF files with my notes from the study sessions, but as I'm doing these live streams, I forget to copy the command output, so sometimes I have to go back to the labs and do them again, just so I can fill out all the boxes or include all the important information. So I'm gonna try to remember to copy paste this stuff to my notepad as we go along. Okay, so back here, yes, enabling the autonomous system configuration. So if we scroll down a little bit, there's the Eigrp named configuration. Now notice here how the configuration is different. So you can enable Eigrp for different address families, IP version 4, IP version 6. We're going to skip IP version 6 in this session and only focus on IP version 4. So let's see, how do we do this? See, I don't remember this by heart because I have not used the named configuration that often. And actually, just to try to figure out. Okay, so we need. Let's actually put this one in here. Let's say classic mode. And then named mode. So router Eigrp, now we need to give it a name. Any clever names you want to suggest? This is always the worst part, coming up with something creative. I'm just gonna be so unoriginal and say 1. Actually, now it would have been a good idea to use the number 1 with the other configuration, so this would be unified somehow. But this one doesn't matter because this is like the instance name for the Eigrp routing process. The autonomous system will come later. And actually, if I read the documentation, let's see what it says about this one. Configures the Eigrp routing process and enters the router configuration mode. Yeah, okay, so it's referring to the, or this is called the virtual name in this example, the Eigrp process. So now here, the autonomous system itself is actually configured here with the address family command. So then let's copy this. So now here we must have 42 because with Eigrp the autonomous system number must match between the neighbors for them to form an adjacency or for them to become neighbors. I don't know if it's officially called an adjacency when you're talking about Eigrp and whether that term is more related to OSPF. Okay, so specifies a network for the Eigrp routing process. So under the address family, you need to configure the network command. So this is what actually enables Eigrp on the interface. And we can configure it slightly differently here on R2. Let me just double check here. Show IP interface brief. So I'm just checking the IP address that is configured here. And so yes, network 192.168.255. And here we can configure it this way as an exact match with this all zeros wildcard mask. So you see the network command, it only enables Eigrp on an interface. It doesn't define what network will be advertised. So this command doesn't mean that now a host route will be advertised to R1. Okay, let's see what else here. Okay, that should be it. So let's try to copy paste this one to R2. Eigrp. Yeah, I'm just making sure that I typed it correctly. So on R2, conf t, like that, and you can see the adjacency is up right there immediately. Once again, let me just copy paste that stuff from here. Like so. So that was pretty easy. Let's see on R1 side. Show IP Eigrp neighbor. We can take this one as well. All right. Okay, now here. So IP Eigrp neighbor. Yeah, so you see that the adjacency is up, or the neighbor relationship is up. Let's copy and paste this one as well. I hope hope I remember what we've done during the live stream. I'm just copy pasting a lot of command output here. Okay, so now one thing I actually want to do. Let's see if we can start a packet capture. Doesn't really matter on which side we do it on. At this point, gig 0/0. Let's see if this works. I hope I have everything installed for Wireshark. Doesn't look like it's doing anything. Oh, now something's happening. Here we go. Remind me later. I don't want to install any updates now. Oh yeah, this is gonna get crowded because we also have OSPF running at the moment. So let's see if we can filter with the Eigrp. Okay, that's better. So what I wanted to do here. Let's look at the contents of the Eigrp hello packet. We don't need to really look at the flags. Okay, here we have. And not this one either. We have all the relevant information here that we want to look at. So why I wanted to pull up this packet capture is because to investigate what the routers are communicating to each other via these hello messages. And why is this important, or why do I like to look at it and approach it this way? Is because the hello packet is what is used to form the neighbor relationship. So in case you need certain parameters to match between those neighbors, they have to be sent within the hello packet, right? Because then besides this, what other packets do we have? There's update, acknowledgement. Honestly, I don't even remember by heart. Let's have a look at the RFC. Eigrp packets, there we go. So we have the update, query, reply, and then the stuck in active situation packets, SIA query and SIA reply. Where does it mention hello packet? Why is it not here? Oh, hello packet is all the way down here. Interesting. What does it tell us about the hello packet? Do we have like is there an appendix that shows us the structure of the hello packet or the different packet types? No? Okay, this is different from the OSPF RFC, because at the end you have an appendix and it shows all the contents. Let me show you real quick. OSPF RFC. So if we go here, there should be that appendix. Right here, OSPF hello packet. So this is what I was looking for in the Eigrp RFC, something similar. But it looks like there isn't anything like that. I don't see. Let's check what it says about the hello packets. So when an Eigrp router is initialized, it will start sending hello packets out any interface on which Eigrp is enabled. Hello packets, when used for neighbor discovery, are normally sent multicast addressed. We will verify this shortly. The hello packet will include the configured Eigrp metric K values. Another important information here, so the K values are sent in the hello packet two routers become neighbors only if the K values are the same. So there's a condition. The K values must match. This enforces that the metric usage is consistent throughout the internet. Also included in the hello packet is a hold time value. This value indicates to all receivers the length of time in seconds that the neighbor is valid. We'll also look at this in more detail shortly, the hello and hold timers. The default hold time will be 3 times the hello interval. Hello packets will be transmitted every 5 seconds by default. There may be a configuration command that controls this value and therefore changes the hold time. Actually, I think they can be changed separately. And I'm not sure if changing the hello timer will automatically reconfigure the hold time as well. We can take a look at that. Hello packets are not transmitted reliably, so the sequence number should be set to 0. This is an interesting note here as well. Let's check that also. So if we go back to the packet capture, here's Wireshark. So this is a hello packet, and let's see a sequence number. So it's set to 0, as it's stated there, because this is not sent reliably. I guess that's why the acknowledgement field can also be 0. Here, another important information, the autonomous system that must match between neighbors. And as it mentioned there, the K values must match as well. So by looking at the contents of the Eigrp hello packet, what can we have, or what parameters could match or have to match between the neighbors? Well, the autonomous system number is 1, and of course the K values, and then the hold time value. Is the hello, I guess the hello value is not even sent here. So the hello timer is not advertised. Because with OSPF, the hello and dead timers must match. So if we briefly compare it to the OSPF hello packet, you see that the hello interval is here, and where's the dead interval? Oh, right here. So these both are advertised in the OSPF hello packet, and they must match between the neighbors. But Eigrp doesn't have the same requirement. And in fact, the hold timer, it is advertised, but it does not have to be equal with the neighbor. The hold timer is actually used to tell the other neighbor how long the local router is valid, or how did it explain it here? I think I'm misspeaking, or I'm not choosing my words very well at the moment. So here, this value indicates to all receivers the length of time in seconds that the neighbor is valid. So basically this hold timer that the router advertises to its neighbors, it tells the neighbor, hey, my hold time is 15 seconds, so that's how long I'm valid. If you don't receive a hello from me in 15 seconds, then you can declare the neighbor relationship down. So that's what it means, and that's how it's different. And we can also test that by reconfiguring the hello and hold timer values. What else? But yeah, that's kind of my approach to understanding how the neighbor relationship is formed. So I like to look at the contents of the hello packet and understand what's being communicated with the neighbor, and then kind of see what parameters would need to match in order for that neighbor relationship to form. I don't know if that makes any sense, but it makes sense to me. Any questions or comments? There's a couple of comments. Hello. Thank you for joining the stream. So question here, do you have a timeline on when you're going for the exam? I have a vague idea, but plans can change. I've actually had the lab exam rescheduled or cancelled, I think 3 times now. The first time, it wasn't because of me. It was the world situation, the labs were closed, and I got a call from Cisco telling me that, hey, we have to cancel your reservation. We're not open right now. And then the following 2 times, I had some personal matters that kind of interfered with the whole process. And still, with the travel restrictions and everything, I really wasn't up for it anyway. So yeah, life got in the way, but I do have a timeline planned. I don't really want to talk about it too much because again, plans can change. So yeah, I just want to kind of focus on my own learning path and keep it to myself for now. But as soon as I have any news that I want to share, you'll be the first to hear about it. I'm sure I'll post stuff on my social media once I have something to share. What else? Where were we? Let's look at the documentation. Yes, one more thing that I wanted to show from the packet capture. So if we look at the IP section here, so you can see that the hello packets are sent to the multicast address 224.0.0.10. And the source is, of course, the exit interface for the packet, or the interface where Eigrp was enabled. I'm kind of confusing this with something else now. So yes, the interface that has Eigrp enabled sending these packets, and the source IP address is the IP address of that interface. The destination IP address is this multicast address 224.0.0.10. Yes, so that's so that's the basic configuration. I'm trying to think in what order to go through the topics from here, because there's some things I want to cover. Let me take a look at the configuration guide, see what's over here. Configuring optional parameters. Oh yeah, passive interface. We could try to look at that as well. Metric weights. This is something we can try as well, or we can try to break some stuff. Let me see. Optional parameters in named configuration. So redistribution, we're not going to do redistribution or summarization today. Yeah, it looks like these topics are a little bit more advanced and go beyond the basic Eigrp configuration, so we'll stick to that and we'll start breaking things. So we talked about multicast, so I actually want to configure a unicast neighbor or a static Eigrp neighbor, so it's going to use unicast. And then you'll see something interesting. So we'll go back to the topology, and then on R3, I'm going to do named mode here as well, just so I can practice that. Show IP interface brief. Okay, so this is the IP address. Okay, conft, so let's do the named mode. So router Eigrp and then the instance name. What instance name do we want to use? This doesn't have to match between the neighbors, by the way. As I mentioned previously when we configured R2, but even if you use named mode in 2 different routers, it doesn't have to match. It's only locally significant. So let me see. Let's say just 3, so we know that it's like R3. Although now it gets a little bit confusing because I used 1 on R2. And then we had the address family, IP version 4, and then the autonomous system. Like so. And now we still need to enable Eigrp. However, here, I'm not sure how you configure the static neighbor. Well, I guess with this one. So let's have a look here. Neighbor. And then let's pair it with R2. 255, 2. Anything else with this command? Do we need to specify the exit interface? Yes, we do. So gigabit Ethernet, I think it was 0/0. Anything else? No. Yeah, so the question mark is a nice feature. It helps you with the command syntax. See, I didn't remember exactly how to configure this. I mean, I had an idea that it's probably the neighbor command, but it was easy to figure out using the question mark. So let's do it this way. And now, let's do this. Let me try to start another Eigrp packet capture. Let's close this one. We don't need to save. Let's start it here, and then we'll do Eigrp. So you see that even if we configured the neighbor command on R3, right there, it's enabled, but we're still not seeing any hello packets from R3 to R2. You see that the source IP addresses, they're just like .1 and .2. So we're on router 2, so these ones are the ones that are being sent out, and these are the ones that are being received on the interface right now. So even if you've configured the neighbor command on router 3, it didn't enable Eigrp yet. So we still have to use the network command. And I've already forgot to copy some commands here. So let me do this. Actually, let me show it here as well, what we've done on router 3. So we've done this. So let me just specify here that this was on R2 and this one was on R3. And then let me grab the neighbor command here as well. This one. Like so. So now what we still need to do is the network 192.168.255.0, and I'm just gonna do it this way now. But again, it doesn't really matter as long as we configure Eigrp so that this wildcard range covers the IP address of the interface. But actually, before I do that, I want to see if there's a way to configure Eigrp, like enable it under the interface. AF interface. Let's see. Gig and then 0/0. Let's see. I think here you can configure those other parameters like the authentication or the hello and hold timers. Yeah, exactly. Yeah, so I don't think there's a separate command to enable Eigrp here. I was trying to check if there's a way to go under the interface and then say something like enable Eigrp or run Eigrp or something. But I don't think that's an option, so we have to specify the network command. Okay, then we'll do it that way. Oops. So we'll copy this one and paste it over here. So now hopefully we should see an Eigrp neighbor relationship form. Maybe. Unless I need to configure it on the other side as well. Let's see what's happening. Let's look at the Wireshark packet capture. Let me scroll down a little bit. Okay, so here you see that we're sending those hellos now. But it doesn't look like show IP Eigrp neighbor. We don't have any neighbors, so I believe that you also have to configure the neighbor statically on the other side as well. That's actually like good to verify, because that's something that I wanted to test. I wasn't sure if you could still form the Eigrp neighbor relationship if only one side has the static Eigrp neighbor configured. So let's go to R2. And the reason why I didn't want to do that, I'll explain shortly. Let's see what happens first. So conf t router Eigrp 1. Notice here, if I now accidentally type 3, then it's going to start another Eigrp instance, and then our configuration would go in the wrong place. So then address family IPv4. Was it like this? Autonomous. I'm trying to remember the command, so maybe I'll like memorize it somehow or put it in my muscle memory. And then okay, so neighbor 192.168.255 and 3, and then the gigabit Ethernet 0/0. Okay, so yes, this is what I wanted to show to you as well. Notice what happened here. Neighbor 192.168.255.1 is down, static peer configured. What does this mean? Why did that happen? Well, I copy paste some stuff. Any ideas? Let me do this one as well. Okay, so on this side should be fine now as well. Show IP Eigrp neighbor. Okay. So now the interesting thing, go back to R1, or sorry, R2, show IP Eigrp neighbor. You see there's only one neighbor now. Why did we lose R1? And here as well, peer termination received. Chat, anyone here? Any thoughts about this? See, there's nothing here. R1 has no neighbors right now. Okay, I'll spare it to suspense. The reason is because we configured static Eigrp neighbors. So if we go back to the Wireshark packet capture, and let's grab a hello here, or we can do that, which is sent from R3 to R2. Actually, I don't really need to look at the contents here. I'll need to look at the IP packet. So see here what has now happened. So the source is a unicast address, as we've seen before when we had dynamic neighbors configured. Now look at the destination. That has changed to a unicast. So this is now sent directly to R2's IP address. So directly from R3 to R2, no multicast. If you remember previously, what do I have here? The destination was 224.0.0.10. So the trick here is that once you configure static Eigrp neighbors on the interface, it stops sending those multicast hello packets. And I guess it stops receiving them as well, because the neighbor relationship between R2 and R3 did not come up until the static neighbor was configured on R2's side as well. But I don't know if we can find any clear information about this in the configuration guide. I don't know where it would talk about that. Let's see over here. Maybe it touched on the topic somewhere here. Maybe this section about neighbor discovery and recovery. Neighbor discovery/recovery is the process that routers use to dynamically learn of other routers on their directly attached networks. Routers must also discover when their neighbors become unreachable and inoperative. This process is achieved with low overhead by periodically sending small hello packets. Okay, this is something different. This is not talking about the multicast and unicast. Maybe something here. To prevent packets from being sent to a neighbor prior to verifying multicast and unicast packet delivery is reliable, a three-way handshake is utilized. Okay, let's see here maybe. During normal adjacency formation, multicast hellos cause the Eigrp process to place new neighbors into the neighbor table. Unicast packets are then used to exchange known routing information and complete the neighbor relationship. No, this is something different as well. See, it doesn't really describe that behavior clearly here, or maybe I'm just not finding the right section. Eigrp packet formats. Here actually, Eigrp packet header. Okay. Anyway, so I can't really find a section here that would explain this behavior in detail. But I have written this document a while ago. Honestly, I didn't even remember what I've put on here. But here, where was that section? Oh yes, that's another thing I forgot to talk about, the common subnet. We can discuss that more shortly as well. But where's the part that I'm looking for? I thought I had a section here about the multicast and unicast, but now I'm not finding it. This section is talking about what parameters need to match between the routers for them to form an Eigrp neighbor relationships. So yeah, there's the authentication, of course, key values, autonomous system, and then the common subnet, the primary address and stuff. We haven't talked about that yet. Okay, so here it is, like closer, like at the very beginning, the section that I was looking for. So here, static Eigrp neighbor relationships require manual configuration. When static Eigrp neighbors are configured, the router uses unicast to send packets to these neighbors. So after a static neighbor is defined, all Eigrp multicasts will be disabled on that interface. Okay, well here it states that. That means Eigrp will not be able to dynamically discover neighbors and establish adjacencies through that interface anymore. In other words, Eigrp cannot use multicast, dynamic, and unicast static neighbor discovery on the same interface. Okay, so multicast is disabled altogether on that interface. Because what I thought that maybe could happen if we go back to the topology. So what we have done here. So we configured static neighbor on here. Eigrp neighbor. So that was R2. So then that means R3 would send unicast packets to R2. But I wasn't sure whether R3 can still discover R2 from received multicast messages. So if R2 kept sending multicast as it did not have a static neighbor configured yet. But that didn't work. So the neighbor relationship didn't form. So that's when I had to configure static Eigrp neighbor on this side. Eigrp neighbor, and then that was R3. So then what happened, why we lost R1? So this not PGP, Eigrp peering. I'm using PGP terminology, this Eigrp neighbor relationship. So as soon as that static neighbor was configured, multicast capability is lost. So that means this Eigrp neighbor relationship went down as well. So that's why we have the situation, let's hide this for now. Situation here that R1 has no neighbors, because we only have this configuration on it so far. Show run section router Eigrp. So you see that this very basic configuration is enabled on R1. There are no static neighbors, so it's using multicast. And now R2 and R3 can see each other because they have been configured as static neighbors. So show run section router Eigrp. Like so. this statement right here. And another important thing to note here, if you remember, the hello packets were not being sent when the neighbor command was configured, when we had only this command configured. So it still required the network command, which is the one that actually enables Eigrp on the interface. Okay, let me go back to this one. I think I had some drawings still here. Let's remove those. So is that clear? Do you understand what we're doing? Any questions or comments? I'll just take a quick break here. And if anyone is watching, how many of you have seen Eigrp in production? So how many of you have actually run and operated Eigrp? I haven't. The only experience I have with Eigrp is from studying it and doing labs in these virtual environments, but never in a real production environment. Okay, let's see, what do we want to do next? I still wanna look at the hello and hold timers, and then maybe we can try to break some things. Let's look at the command reference here. Passive interface. Oh yeah, we didn't look at passive interface either. Passive interface is a good command. So yeah, here it actually explains it, what passive interface does. So it suppresses the Eigrp hello packets and routing updates on interfaces while still including the interface addresses in the topology database. So basically it allows the connected network to be advertised, but it will not send or receive hello packets on that interface, so it cannot form Eigrp neighbor relationship on that interface. We can actually try to do that on one side, I don't know, on R3 for example, because a common way to configure this, well, there's two options. So you can enable the passive interface under the interface, so prevent those interfaces from participating in Eigrp, like one at a time. Or you can do passive interface default, which of course means that all interfaces with Eigrp configured will be passive at the start, but then you can do no passive interface then to allow that neighbor to form Eigrp neighbor relationships. That sounded like a confusing explanation. Let me see if I can find that in the command reference here. So this one is in classic mode, by the way. So let's do both. So in classic mode, you could do it like this. Let's see here. So passive interface. So yes, you could do it like this. Passive interface. And then, yeah, our interface here. Let me do this. Or passive interface default and then no passive interface, like so. This is how you would do it in classic mode. I personally prefer this way because then you don't accidentally enable Eigrp or form Eigrp neighbor relationships on interfaces where you don't want to. And then let's see it on the named configuration mode. Let's see if it's, is it here? Metric weights. Okay, this is going to be a little bit different. See here how you would do it is under the address family interface to configure a passive interface. Okay, let's have a look at this. I need to see how you can enable the default passive interface. But first let's look at this. So you could do AF interface and then gig and do passive interface. So that's one way. Well, let me see how to do the other one. So conf t, it must be here. Let's see what we can find. Default AF interface. What? Default AF interface default? Somehow that doesn't seem right. Hold on. Set a command to its default. No. Okay. This means different. So I guess default, the first syntax means that you return the command to its default value. So I guess if you had changed the metric value, for example, and you do like default metric, then it returns that. That's how I'm interpreting that. Yeah, like this, yeah, that seems too weird. So it's probably AF interface default. Yes, and then we can do passive interface under here, I'm guessing. Yes. But notice here that this description is interesting because it says suppress address updates on an interface, but it suppresses hello packets, so EIGRP cannot even form, or the neighbor relationship cannot form. Because sending updates is the next phase. So this is a little bit misleading in my opinion. Because reading only this, it makes it sound like the EIGRP neighbor relationship can be established, but for some reason updates would not be sent or received. But let's do that. This is gonna break our neighbor relationship though, until we cancel that with the no command. So the neighbor relationship should go down now. Indeed it does. And the reason being, we do show run section router EIGRP. So this is what we have at the moment. I'm just gonna copy paste that to my notepad. This is already a mess, by the way. I probably have to go through the examples again on my own. Okay, so what did we put on here? So the other option was the AF interface default and then passive interface. So then now we can go under the AF interface gig 0/0 and then do no passive interface. Like this. Let's see. So I'm just gonna exit out of here. So now in the hierarchy, by the way, this might be a little bit confusing to follow along sometimes. So basically, just before we were right here. And now we've gone up one level, so we've come out of the interface default configuration mode, and we're back under the address family configuration. So if you follow the tree here, you can kind of keep track. So now we're under the address family configuration. So now let's go under the gig 0/0, like that, and then do no passive interface. So now that Eigrp neighbor relationship should come back up. Yes. So that's how passive interface works. And now we've actually spent a lot of time on named mode. Let me see. Need to remember to do something on R1 as well, so we can take a look at classic mode. By the way, in classic mode, I think there is a way to enable Eigrp under the interface directly. So let me just double check that. Interface gig 0/0 IP Eigrp probably. Where's my question mark? No. Eigrp? No. Well, let's see. What am I missing here? Is it not like IP Eigrp? Or maybe it was with IP version 6 that you can enable Eigrp directly under the interface. I'm not sure now. Yeah, because here is how you change the hello timer and hold timer for Eigrp. We can come back to that shortly, but I guess there's not a way to configure Eigrp under the interface. Any comments? Only OSPF. Haven't run it before. Oh, this is probably answer to my previous question if you've run Eigrp in production. Yes, so similar answers. I also haven't seen it in productions. Only OSPF for me as well. OSPF and PGP. I haven't even seen ISIS. I know maybe some service providers run that, but I have very little experience or knowledge with that protocol, by the way. It's just another thing that I need to learn at some point. Okay, let's forget about that for now. Where was I then? What do we want to do next? So yeah, we looked at the passive interface. I guess we can try to break some things, like the metric weights. And also another thing, I don't know how crazy I want to get with this lab and with this testing, because I'm guessing that under the default interface, you can change pretty much all the parameters that you can change under a real interface. So I'm thinking about the inheritance. So if you change the metric weights under the default interface, we could configure it like this, how it's shown here. But then if we want to do different values under the gigabit interface, which should override these values. So, because it's more specific configuration. Shall we try that? Why not? Actually, before I do that, let me just get some more water. And actually, because we're going so crazy here, oh, I see another comment. You've seen some ISIs on Juniper routers in your MPLS network at work. Yeah, that's pretty cool. I actually don't have much experience with Juniper either. I don't know, 8+ years ago, I may have touched a Juniper router like once or twice, but that's about it. Unfortunately, I don't know how to command those devices. It's something on my list that I'd like to learn eventually, but for now it's only Cisco. But anyway, I was gonna say, because it's getting a little bit crazy here, and since it's Cisco Live week, I brought something out here. This is kind of funny. Does anyone recognize this? Can you see this? Hold on, I need to check myself from the camera. I don't know where I'm pointing. This one. Wait, which way do I put it? This way? It's a little squished because it's been sitting in my closet, like with some other stuff. But if you've ever been to Cisco Live, usually at the customer appreciation party, they give you some kind of hat. And this is from the 30-year celebration. So whenever that was, I can't remember anymore. So yeah, we can have some Cisco Live vibes here. And oh, one more thing. Let's see if this still works. Yeah! We're having a party now. Okay, let's go. Alright, so let me see if the lights are really distracting, by the way. I can turn this off. I don't know if... how do I look? Okay, so we were about to break things. Maybe, actually, what I'll do... If we can get this to work, I'm gonna turn the lights back on. Alright, so let's try to break the metric weights, because this is one of the parameters that have to match between the neighbors, or between the routers, for them to become Eigrp neighbors. So yeah, let's break things. Let's go on R3, for example. And I'm gonna try that inheritance thing first. So let's see what metric values it even advertises. So let's say, where's the command reference? This one. Let's do it like this under the default interface, if it works. So we'll try it like this. So AF interface default, and then this command, like so, and then we'll go under the gig interface and we'll do something different, like metric weights, I don't know, 1 1 1 1 0 0 0, something like that. Okay, let's see what happens. So once we paste these commands, our neighbor relationship should break. Do I still have the Wireshark running? I do. That's perfect. Okay. So right here. Oh no, but now I have to go down the whole 3. Eigrp 3 address family, IPv6 unicast auto, and 42. And now we can paste this stuff. Yes, and you see immediately this error message that the K values are mismatched and the neighbor relationship is down. But now, oh no, why did I exit out? So what I want to see, let's go back to Wireshark. Let's see a recent hello packet. Where do I have the K values? Parameters right here. Okay, so it's sending the ones that I configured under the interface. But now the question is, why? So there are like, because there are like 7 values configured here, but there's actually only 6 K values. So the first one was actually for TOS. And what has happened here? Why? Oh, maybe because I have like zoomed in on the page to have the text a little bit bigger. Okay, so let's do that under or on the other router as well. And on that side, actually, maybe to make it even more confusing, we can do the AF default and not configure anything specific under the interface. I don't know if you're following along. You'll see what I'm gonna do here. So, okay, so show IP Eigrp neighbor. So nothing is here right now. So conf t router Eigrp 1 address family. Trying to type the command out again. IP version 6 unicast autonomous system 42. And now AF interface default. And then what was it? Metric weights 1 okay. Metric weights 1. So remember, this one is the TOS, and now K1, K2, K3, K4, K5, K6. They should match now. Hopefully. Yes. So the Eigrp neighbor relationship has been reestablished. Show IP Eigrp neighbor. Like so. Now we can turn on the lights. Yeah, let's celebrate a little bit. Like that. All right, let's see, what next? So we looked at the K values. Yes, the hello and hold timers. We can look at next as well. And actually, we could enable the... I'm thinking if we want to bring R1 here as well, so we can see the different configuration in classic mode also. And actually, we didn't check how to change those metric weights in classic mode. So where is it? Here. So I guess with the classic mode as well, you have this TOS value here. And actually now I'm trying to remember or understand how the classic mode and named mode work together, because if you look here, the classic mode is using 5 metric weights or 5 K values. But the named mode, where was it? Here. The named mode is using 6 K values, the metric weights. So now I am not sure how exactly that works. Let's bring in R1 here. Let's see what happens. So conf t. So router Eigrp 42. I almost wrote 1 here now. So then let's do neighbor 192.168.255.2. And then the outgoing interface, gigabit, Ethernet 0/0. Like that, so it should start sending hello packets to R2. Can we see anything here? Yes, we can. You see the source is R1, but the K values will not match right now because we just changed them on R2 side. And also R2 does not have that neighbor statement configured. So we actually need to do that as well. So conf t. Actually, let me just see if I can make this a little bit faster. Show run section router Eigrp. What we want to do here is, well, let's copy this one. Conf t. And then neighbor 192.168.255.1 and gig 0/0. So now we should start seeing those K value mismatch messages again because we've changed them on R2, but they're still the default values on R1. So how is this going to work now? Let's see here actually on Wireshark quickly. So, oh no. So this one, for example. Oh, okay. This is something that I did not expect. So R1 is sending the K values put to the max. What? What was that for? Now this is different. Did you catch that? That was weird. Okay, so I'm looking at a packet sent from R1 to R2. But there is actually 6 K values here. There's something I'm not understanding here. Because with the command here in classic mode, the only thing we can change is K1 to K5. So if R1 is still sending the K6 value somehow, it's set to 0. How can we change this? So if we put all K values to 1, oh, this is too crazy. I need to test this out now. This is weird. Okay, so let's change it on this side first. So the metric weights, where did I change them? Under the address family. Let me go go from here because that keeps erasing. So if we do it like this, wait, 1, 1. How many ones is that? I think that's correct, hopefully. So if we do it like this, now we're gonna get even more of those log messages because R3 is gonna go down as well. Yeah, here we go. So that means we have to change that on R3 side as well. So here, like that. I might have to cut the stream soon because it's getting confusing and my brain is slow. So router Eigrp 3. And then address family, IP version 4, unicast, and then auto and 42. So now we can paste this. Okay, so now R2 and R3 have formed an Eigrp neighbor relationship. R1 and R2 will still struggle because the K values do not match, and that's why we're seeing this horrible amount of these log messages. But now I want to go to packet capture and I want to see. So here, for example, what from 2 to 1, we're sending all of these are 1. And from 1 to 2, see there's this K255 again. I'm gonna screenshot that. I wanna investigate what that is for. Let's take this whole thing. Okay. So what I want to figure out now, so on R2 side, all of these K values are set to 1. So how can we change that on R1 side, which is running classic mode? Because again, if you look at the syntax, in classic mode, you can change only K1 to K5. So let's try that. I'm gonna try that command again. So, okay, it wasn't here. So metric weights. So see here, if we put everything to 1, K1 is 1, K3, K4, K5, and then that's it. That's the end of the command. So that's all we can change with this command. So let's see what happens here. Okay, so now, yeah, you see it's not possible for us to change K6. This is really interesting. So according to this Wireshark packet capture, R1 is sending this packet with the K6 value, but there's no way to modify it. We can only change K1 to K5. Yeah, and if you look at this, the source and destination IP addresses, so they're coming from R1 to R2. K6 is here, but it's 0. And again, it's not possible to change it with the metric weights command in classic mode. Wow. So I guess the way we would have to fix it is change that to 0. So now R3 is going to go down and hopefully R1 will come up. Show IP Eigrp neighbor. Yes. So now we need to fix this on R3 as well. Eigrp 3 address family. IPv4 autonomous system and 42. And then we go under the interface 0/0 and then change the metric weights here as well. That, but include another 0. And now we should have all the neighbor relationships come back up. So R1 should have a neighbor relationship with R2, only we haven't configured between R1 and R3. And then, so R1 should have 2 neighbors. Excuse me, R2 should have 2 neighbors. Like so. So R3 here and R1 here. And then these guys have only 1. Yeah, R2 is there. Yeah. So this is how you break things and you learn stuff. Let me actually, is this still on? Yeah, let me turn this off. There we go. Let's put this one in here. So the little control to, or the switch to turn the lights on and off. Maybe I'll become smarter by the power of the Cisco Live hat. Okay. Maybe one more thing. So we'll look at the hello and hold timers, and that's it. We're gonna leave authentication for another time because we've already been running for quite long with all this shenanigans during this live stream. So let's take a look at that. Let me go back to the configuration guide. Let's see where we can, where it shows us how to change those. Optional parameters, is it under here? Well, it's not really an optional parameter. How to configure Eigrp. Maybe it's in a different section. Any questions or comments, by the way? No redistributions and summary. Yeah, we don't want to look at this right now. Where does it show how to configure the hello and hold time? No, this is something else again. Oh, here. Finally. Adjusting the interval between hello packets and the hold time in autonomous system configuration. We'll look at that next. Give me a quick break here. All right, so let's try to collect the commands in Notepad again and then just paste them, or maybe I'll try to type them just for the muscle memory again. Easier to remember the commands that way. So in classic mode, you configure them under the interface. So I kind of briefly looked at that before when I was trying to search for something else. So here's the syntax. So under the interface, IP hello interval, Eigrp, then the autonomous system number, and then the seconds that you want to specify for the hello interval. So it configures the hello interval for an Eigrp routing process. And here's the hold timer. So IP hold time, Eigrp, and again, you need to specify the autonomous system number, and then you can define the seconds. So let me see, I don't know what values we want to configure for that. Let's see under here. Oh, I didn't write the metric weights here actually. Let's see quickly. Show run section router Eigrp. So this is how you configure it. So we've already done this, and now, so we need to go under the interface. And the syntax is IP hello interval. Where is it? IP hello interval Eigrp. Then it was the autonomous system number. And then let's see, what kind of timer do we want to put? Let's say 15 seconds, for example. And the other one, the hold timer. So IP hold time Eigrp 42, and let's say, I think, let's say twice that for now. Notice here how this is different. So it's hello interval, but then hold time. And actually, before I touch the hold time, we can see if changing the hello timer automatically changes the hold timer. I don't think it does, but we can verify that. So if I do show IP Eigrp, is it interface command? And then, or is it detail gig 0/0? Actually, I want one more thing that I want to check. Does this change the output in any way? Okay, so you have to put the detail first. Like that. Okay, here you can see the current hello interval and hold timer values. Actually, I was going to configure the new hello timer exactly the same as the hold timer. Let's see what happens. Interface gig 0/0 IP hello interval Eigrp 42 and then 15 seconds. I guess that was the syntax. Yes. So let's see what happens now. So do show IP Eigrp interface detail and gig 0/0. So you see it didn't automatically change the hold timer. So these values are now equal, which, yikes, I'm not sure how this is going to behave. Because how this works. Okay, let's draw some things here. Oh, I still have this one here. Let's remove it. So you have R1 here and R2. So now this R1 is sending this Eigrp hello here. Eigrp hello. And that contains the hold timer of 15 seconds. So basically it's telling R2 if you don't hear from me in 15 seconds, declare me dead. Like I'm gone if you don't hear from me in 15 seconds. But now we're also sending the hellos every 15 seconds. Hellos every 15 seconds. I can't type. 15 sec. So I guess there's not enough difference for the neighbor relationship to flap, because we can cause that next as well. But let's see here now. Okay, so let's change the hold timer for now to the value that we specified before. So IP hold time Eigrp 42, and then I think it was like that. That's what we wanted to do. Okay. So now here are our hello and hold timer values. And we should see that in the packet capture as well from R1. Yes, here it is. Hold time has changed to 30 seconds. And once again, the hello timer value is not here. It's not advertised. So basically, again, R1 is telling R2 to wait 30 seconds for another hello. And if a hello is not received, then you can declare the neighbor relationship down. So now let's see what happens if we actually configure the hold timer lower than the hello timer. So let's reverse those original values. So where was it? Can I see all the way up here? So the default values are 5 seconds for hello and 15 seconds for hold time. So let's reverse those. So now we have hello interval configured at 15 seconds. So let's change the hold time to 5 seconds. Let's see what happens. So 5. And actually I should have done show IP Eigrp neighbor. So you can see soon what's going on here. Let's give it a few moments. So maybe you see a pattern here. Hold timer expired. Neighbor is down. Oh, neighbor is up. New adjacency. And then again. So this pattern repeats. So what we've done, as you may guess, so here you can see the hold time. So if we keep repeating that same command, you see that it doesn't go above that 5 seconds that we've configured on the other side. So let's go to Wireshark again. So here, where was it? Yeah, it was 30 seconds. But now, where is it? Acknowledgement, no. So, no, I've looked at the wrong one again. I'm trying to capture the, let me see, can we do like, specify also, I'm not sure how you do another parameter here. IP, is it the source? And is it like equal 192.168.255.1. I'm not sure how we can remove. Yeah, that's not exactly what I wanted. I don't know how to use Wireshark very well. Here we go. So this is what I wanted to see. So now we're advertising a hold time of 5 seconds. Let's go back to this one, Eigrp. So what's causing this flap is that once that 5 seconds expires, right here, so you see that the neighbor relationship goes down, but then R1 sends a new hello packet every 15 seconds. So that's when they reestablish the Eigrp neighbor relationship. But then once again, after the next 5 seconds, the whole timer expires again, and the neighbor relationship goes down, then back up, back down, and so on. That's why it repeats. So this can be a little bit dangerous in a way when the Eigrp hello and hold timers do not need to match, and there's no protection really against that the hold timer value is configured lower than the hello timer value. And here's actually something interesting as well on R1 side. So you see that is down peer termination received. So the termination is coming from R2 side. So R2 is basically saying, hey, I haven't heard a hello from you in the whole time that you told me, so I'm going to terminate this neighbor relationship. Okay, so let's reconfigure that back to some higher value so we don't see this message anymore. So now the adjacency has come up, and now it's not gonna go down again because the hold timer should never go under 15 seconds really, because it starts from 30 and we're sending hellos every 15 seconds, and that's gonna restart the timer. So if we keep repeating, you see here, it doesn't go below 15. But I don't think there's a way to really see the value that was received from the neighbor. I don't know if it's stored anywhere. Show IP Eigrp interface. What was it? Detail. Yeah, gig. 0/0. I don't think there's anything here to describe what was received. So you see, these are the local values. So I'm sending hellos every 5 seconds, and I am telling my neighbors to wait for 15 seconds to receive a hello from me. So that's what it means. So pretty important to understand that and how it behaves differently from OSPF, for example. Okay. Any questions or comments? Actually, we only looked at the classic mode. We haven't looked at named mode yet. So let's do that, and then we'll probably finish this stream. So here in named configuration, let's see how to do this. So I guess you go under the interface. Yeah, again, you can do it either like default or specifically under that interface. Yeah, we can do it under the interface directly. It doesn't matter. Okay, so if we go here, let's go. Oh, it's like a huge mess here. So you would do AF interface gig 0/0, and then I already forgot the syntax. Hello interval 10. Hello interval 10. I'm just gonna use the same values as here, it doesn't matter. And then hold time 50. Like so. So that's how you configure it under the named configuration mode. Let's go here. Conf t router Eigrp 1. Next time I need to come up with some more creative names. And then address family, IPv4, unicast, and then autonomous system number 42, and then the interface gig 0/0. Let me see if I can remember. Hello interval 10 and hold time 50. Was it like that? Yes. Okay, so if we check Wireshark once more, let's see what we're sending and receiving here. Yeah, hold timer has changed to 50 now. So yeah, if we check on R1, no, show IP address number. This is what I want, yes. So again, basically the only indication you can have of the received hold time value is from this output. But again, it doesn't give you it exactly. So if you repeat it, you can probably guess what the hold time value is. So you see here that we're not going above 50 and we're not going below 40. So you can probably figure out that the hold timer is most likely 50 seconds and the hello timer is most likely 10 seconds. Tells you how long the neighbor relationship is valid. All right, so I guess that's a good point to end the stream, but before I do that, let's just check what we have. Show run section router Eigrp. Let's see what kind of mess we've made here. And actually we also need to look at show run interface. And then this one. Oops. So if I copy all of this, let's paste it in here. And then kind of let's remove this mess here. And all of this we don't need. So this is kind of what we had on R1. So this is in classic mode. And then named mode. Let's do the same command. Here. And then finally on R3. Like so. So you can see that the named mode configuration is maybe somewhat more clear once you get used to it, because everything is done under the Eigrp routing process. Whereas with the classic mode, let's put this in here. With the classic mode, you have configuration in different parts in the running configuration. So you see some of the configuration is under the router Eigrp process, which of course makes sense, but some of the configuration is under the interface. So I can understand why named mode became a thing, or why they developed named mode. And also named mode supports IP version 6 with the address family configuration. And I guess one final little thing that we can look at, because there's a command to change from classic mode to named mode directly. Let me see if I can find it in the documentation. I think it was stated somewhere here already, unless I missed it. It's something Upgrade Cli or whatever, if I remember correctly. Monitoring and maintaining named configuration. Oh yeah, this is another good thing about Cisco documentation, by the way. So there are these configuration examples at the end of the guide. So this gives you exact commands that you have to enter. So this is actually something that I was looking for at the beginning of the stream. I'm like, why is it so difficult to find just basic Eigrp configuration? Well, looks like it was just at the very end here. So here it clearly tells you how to enable Eigrp for classic mode. Very simple. And then the same thing, but for named mode. Because in the previous examples, at the top of the document, there was like VRF and everything else included, all that crazy weird stuff. Well, not weird, but yeah, we were supposed to stick to basics in this session. So yeah, loads of configuration examples here. But yeah, we'll look at more of this next time, I guess, because we didn't touch on authentication yet. And I am not spotting the command that I'm looking for. Let me go back up here, unless it was somewhere on this side, actually. Here, yes. Classic to name mode conversion. So this is the final thing we'll look at, and then we'll be done with the stream. So here we go, Eirp Upgrade Cli. I guess this is global configuration mode. Let's see if there's something we should know here. If multiple classic mode configurations exist, you must use this command per Eirp autonomous system number in classic mode. Oh, or maybe you do it under the Eirp process. Command blocks the router from accepting any other command until the conversion is complete. The console is locked. The time taken to complete the conversion depends on the size of the configuration. However, the conversion is a one-time activity. Okay. Oh yes, and this is a one-way command. So the Eirp Upgrade Cli command is available only under Eirp Classic router configuration mode. Therefore, you can convert configurations from classic mode to named mode, but not vice versa. So yes, that's good to know as well. So if you're already running Eirp named mode, then you can't revert back to classic mode. This is actually a good thing to know for the Eirp lab exam, because if you somehow start with named configuration mode, and then you realize later that you have to use classic mode, there's no easy fix for that. You can't run this command and then it'll revert back to classic mode. You have to start all over again. So basically this Eirp, Eigrp. What was it? Upgrade Cli. So then it goes from classic to named, but not back. So it's a one-way command. One way only. Okay, what else do we need to know? After conversion, the running configuration on the device will show only named mode configurations. You will be unable to see any classic mode configurations. Yeah, to revert to classic mode configurations, you can reload the router without saving the running configuration to the startup configuration. Interesting. Okay, there's a whole lot of text about the classic to named mode conversion. What? That's it? But where do I configure it? Is it under the global configuration or under the Eigrp process? Where did it say that? And where's the configuration example? Let's try. I'm not sure if that command is even going to be available, but we'll find out. Conft, okay, Eigrp, let's see. Okay, it's not here, so router Eigrp 42. Let's see. Okay, looks promising. We have an option for Eigrp. Yeah, Upgrade Cli. So it's under the Eigrp routing process. Right here. Upgrade the classic mode config to name mode. Oh yeah, you need to give it an instance name as well. Yeah, because like this, it's not gonna work. So, yes. Convert. And that's it. Configuration will be converted from router Eigrp to convert. Are you sure you want to proceed? Yes. All right, let's see what it has done. Well, that was a fast conversion. Well, then again, we didn't really have much configuration in here. Oh, it looks like it re-established the Eigrp neighbor relationship as well. Or resynced it. Show router, no. Show run. Section router Eigrp. And now we've converted to named mode. But now I'm curious. Router Eigrp 42. So that's in use in Eigrp named mode. Let me see here. So you can't do anything with classic mode. What if we do another Eigrp routing process or another instance? I guess that should technically work, maybe. Yeah. Show IP protocols. Let me check something. Yeah, we're running OSPF. Yeah, so it's created another instance. So we're now running Eigrp 42, which is run under the Eigrp named mode. And then we're also running Eigrp 1, so autonomous system 1, that I just enabled, but nothing's configured there right now. So there's no neighbors or anything. Does this one show? Well, this one doesn't show really information about the neighbors either. It's more about the K values and like general information about the routing process, I guess. Show IP Eigrp neighbor. Yeah, so the other Eigrp process shows up here as well, but there are no neighbors because we haven't configured anything. But yeah, that's how you can upgrade the Cli from classic mode to named mode. So ruin. Section router Eigrp. Okay, any questions or comments? Is anyone still watching? It's been pretty quiet today as well. If not, I will stop the stream shortly. I'm just checking if there was anything else I wanted to cover. I mean, besides authentication, we didn't cover that yet, but something about basic Eigrp configuration and neighbor relationships. So let's see what we've done here today. Let's see, summary. So, or we did classic and named mode. We looked at dynamic and static neighbors, or I could say multicast and unicast. Then what else did we do? Metric weights slash K values. And then we did hello and hold timers. And then we did upgrade Cli. Was that it? Did we do anything else? I think that was about it. We covered quite a lot. And maybe in some parts it was a little bit difficult or confusing to follow, because I came up with random ideas to test. But yeah, that's how you learn. You break things and fix things. Maybe I should type that here as well. Break and fix. That reminds me of the Wreck-It Ralph, and what's the other one? Fix-It Felix, is that what it's called? So yeah, that's the best way to learn. So first you wreck it and then you fix it. Okay, I don't really see any activity in chat. So I'm going to end the stream here. Once again, thank you for everyone who joined the stream. Thank you for watching. And I don't know when I'm doing the next stream. The rest of the week is pretty busy for me, but hopefully soon enough. I'll see if I can squeeze in a short stream somewhere. If not, might have to come back to Eigrp or maybe something else even another time next week. But yes, until then, I hope you have a great week. Enjoy your time. Make sure to rest as well, that's very important. But yeah, once again, thank you for watching and I'll see you next time. Bye bye.